If you went back to, say, the year 2005 and told a room full of Wall Street analysts that a company making microchips for teenage gamers was going to entirely dethrone Intel,
Oh, they would have laughed you right out of the booth.
literally laughed you out of the room,
Yeah.
you'd have been told you just don't understand business. Because, I mean, at that time, Intel was the mightiest, most impenetrable fortress in the technological world.
The absolute gold standard.
Right. And yet that fortress wasn't breached by a direct competitor
Yeah.
building a better, faster version of Intel's own technology. It was bypassed entirely by a company making, of all things, video game graphics.
It's a completely wild story.
It really is. Welcome to this deep dive. Today, we are extracting the ultimate strategic lessons for students of business history in competition. We've got a great stack of sources today, including excerpts from an analytical piece titled Architectural Pivot, The Silicon War for AI Dominance, a really detailed comparative strategy chart, and a timeline of hardware evolution from the 1990s right up to the 2020s.
And it really is a remarkable shift to analyze, primarily because it maps out this massive industrial flip that almost no one saw coming until it was already over.
Which is exactly why you, listening right now, should care about this story. Whether you are prepping for a high-stakes strategy meeting or, studying business, trying to understand how massive empires rise and fall.
Or if you're just trying to wrap your head around the current artificial intelligence explosion.
Exactly. This deep dive is going to give you a completely new lens. We're going to reveal how these highly technical, seemingly obscure architectural choices made decades ago ended up dictating the winners and losers of our modern economy. We are breaking down how Intel was outmaneuvered by NVIDIA.
What's fascinating here is that technological revolutions rarely arrive in the form industry incumbents expect. I mean, they don't announce themselves with a formal declaration of war.
Right, they sneak in.
They do. They often disguise themselves as toys or, niche applications, operating completely outside the main arena of serious enterprise competition.
And a toy, in this case, being rendering shiny digital water and explosive particle effects for video games.
Yeah, exactly.
But to really understand how the entire computing market flipped upside down, we can't just look at the business side. We have to establish the fundamental physical difference in how these two companies' processors actually, think.
We have to look at the silicon.
Right. So let's rewind to the 1990s and early 2000s. Intel's dominance in that era wasn't just a lucky streak. It was this unshakable fortress built on three deeply reinforcing strategic foundations.
And that foundation was almost impossibly solid. First, you have to look at how Intel controlled the actual architecture of mainstream computing.
The x86 design.
Yes, their x86 processor design. It wasn't just popular, it became the absolute industry standard for personal computers and heavy-duty enterprise servers.
So if a developer was writing software, they wrote it for x86.
Exactly. It was the default setting of the digital world.
But wait, a design is just a design.
Yeah.
I mean, anyone could theoretically try to make a better design, right? So why was Intel so untouchable?
Because of the second pillar, which was their absolute brute force leadership in semiconductor manufacturing, Intel didn't just design their chips.
Built them.
They owned the massive multi-billion-dollar factories that printed them. This is what we call an integrated manufacturing model.
Wow. Okay.
And for decades, they were consistently pushing the physical boundaries of chip miniaturization and performance better and faster than anyone else on Earth.
And then you had that third pillar.
Right. Because of those first two advantages, Intel cultivated an enormous ecosystem. Software developers, hardware manufacturers, massive corporate clients, they all revolved around Intel's architecture.
It's like a gravity well.
Exactly. These network effects created a gravity well that constantly reinforced Intel as the center of the computing universe.
Yeah. And at the very heart of that universe was the CPU, the central processing unit.
Yeah.
This is where we need to get into the mechanics of how these chips operate.
The underlying physics of it all.
Yeah. The CPU is fundamentally an engine of sequential logic. It executes tasks one step at a time. It's very logical, very linear.
Which makes it absolutely perfect for running your laptop's operating system, or managing a bank's database, or executing the formulas in a massive spreadsheet.
Task A must finish before task B can start.
Right. Sequential logic is incredibly powerful for general-purpose computing. When you're clicking around your desktop, you want a processor that can pivot instantly from opening a browser to saving a file to checking your email.
Fast and linear.
Yes. The CPU is a master of juggling those sequential demands incredibly quickly. And for decades, this architecture of competition appeared, well, permanent.
Okay, let's unpack this. Is a CPU basically like a single ridiculously brilliant mathematician?
I like that.
Like imagine an absolute genius sitting in a room solving a complex multi-step equation perfectly step by step. They're incredibly fast, but they can still only write out one line of the equation at a time.
Right.
Meanwhile, over in a completely different sector in the 2000s, NVIDIA was building GPUs graphics processing units, and rendering a complex visual environment for a video game requires a totally different kind of math.
Completely different.
It relies on parallel computation, meaning instead of doing one thing at a time very quickly, a GPU executes thousands of smaller calculations simultaneously.
Simultaneously, yes.
So if the CPU is the brilliant solo mathematician, is the GPU like an army of 10,000 middle schoolers all solving simple arithmetic at the exact same time?
That analogy captures the architectural divide perfectly. Think about what it takes to render a modern video game environment.
It's a lot of data.
It's huge. If you want to draw a million individual pixels on a screen, and you need to update the color and lighting of every single one of those pixels 60 times a second.
You don't need one brilliant mathematician.
Exactly. The mathematician would be too slow going pixel by pixel. You need the 10,000 middle schoolers all shouting out pixel colors at the exact same moment.
That makes total sense.
The structural design of a GPU is literally thousands of tiny, simple processing cores working in parallel.
But I have to push back on something here. If parallel processing is so useful, why didn't Intel, with all their billions of dollars in manufacturing might, just build their own army of middle schoolers?
Whoa!
Like, why leave that completely to NVIDIA?
Because of the innovator's dilemma and, frankly, the nature of their profit margins. For a very long time, the brilliant mathematician didn't care about the middle schoolers.
They weren't a threat.
Not at all. This fundamental architectural difference had zero strategic consequences for Intel's core business. CPUs dominated the heavy lifting of mainstream, highly profitable enterprise computing. GPUs were viewed as, peripheral accessories.
Right. You bought an expensive Intel CPU to run your actual computer.
And maybe you bought an NVIDIA GPU on the side to make your video game look prettier. They weren't fighting for the same territory. Intel had billions of dollars sunk into optimizing by 86 sequential logic.
So pivoting would hurt them.
Pivoting to parallel processing would have meant cannibalizing their own incredibly lucrative business model for what was just a niche gaming market.
Which makes total sense at the time. I mean, an army of simple calculators doesn't threaten the brilliant sequential mathematician until the type of map that the entire global economy demands suddenly drastically changes.
That's the inflection point.
Let's trace how this structural shift actually happened, because it didn't happen overnight. Looking at our timeline from the sources through the 2010s, we see a distinct progression.
Right.
First, there's the expansion of machine learning from around 2010 to 2015. Then from 2016 to 2020, we enter the deep learning revolution. And finally, from 2021 onward, we hit the generative AI explosion, the era of ChatGPT and massive neural networks.
And this timeline represents the exact moment where the physics of computation violently collided with the economics of the future.
Yeah.
We have to ask, why did this specific evolution toward artificial intelligence favor NVIDIA so heavily?
It really comes down to what AI actually requires mathematically.
When you are training a modern machine learning system, especially a deep neural network, you aren't using sequential logic. You're processing millions, sometimes billions of parameters across vast data sets simultaneously.
Give us a tangible example of that. Like, what does that actually look like under the hood?
So think about teaching a computer to recognize a picture of a cat.
Okay, classic AI example.
Right. You don't give it a step-by-step rule book. You feed it a million pictures of cats and a million pictures of things that aren't cats. The neural network has to adjust millions of tiny digital weights and biases, essentially tweaking millions of variables by a fraction of a percent every single time it looks at an image.
All at once.
All at once, until it learns the pattern. It mathematically requires massive parallel computation.
Oh, wow.
Yeah.
It's the exact same math as drawing a million pixels on a screen 60 times a second.
Exactly the same underlying mechanism. It is the precise workload that GPUs were inherently built to handle. The foundational requirement for artificial intelligence aligned completely with GPU architecture.
But wait, I have to challenge the prevailing narrative here. It sounds like NVIDIA just got incredibly lucky.
Well,
I mean, they were trying to sell graphics cards to teenagers playing Call of Duty, and suddenly neural networks required the exact architecture they happen to have sitting on the shelf. Are we giving them too much strategic credit for what was essentially a massive historical accident?
If we connect this to the bigger picture, we uncover the first major strategic lesson from our sources for anyone analyzing business competition. Was it a lucky, unforeseen technological alignment? Absolutely.
Right.
But luck is only the spark. Strategy is the engine that actually captures the energy. The lesson here is that architectural decisions made decades earlier can produce massive, unexpected advantages when new technologies emerge.
So they capitalized on it.
Masterfully. It was a lucky alignment, but NVIDIA didn't just passively sit back and sell gaming chips to AI researchers.
Right, they saw the embers and poured gasoline on them.
Precisely. They recognized this opportunity years before it became mainstream and aggressively reframed their entire corporate identity. They stopped calling themselves a graphics processor manufacturer and started pitching themselves as the providers of engines of accelerated computing.
That's a huge shift in branding.
And by the early 2020s, data centers weren't just buying a few GPUs to test out AI models. They were deploying massive clusters of tens of thousands of them. NVIDIA transformed themselves into the absolute backbone of the AI infrastructure economy because they actively leaned into that paradigm shift.
And here is where we get into the truly brilliant and arguably ruthless part of their strategy. They didn't just sell the hardware. Because, I mean, anybody can theoretically try to reverse engineer hardware.
Eventually, yes.
Instead, NVIDIA built a trap. They constructed this highly lucrative, incredibly sticky ecosystem to make sure that once those AI researchers and developers started using NVIDIA chips, they could never, ever leave.
This is the critical pivot of the entire story. While that architectural alignment provided the initial spark, NVIDIA spent years and billions of dollars actively building a platform ecosystem to widen their economic moat.
The software side.
Right. Back in the 2000s, long before AI was a buzzword, NVIDIA introduced a software platform called CUDA.
That's spelled C-U-D-A for anyone taking notes.
Yes, CUDA. And what it actually did was revolutionary for developers. Before CUD existed, if you wanted to use a GPU's massive parallel processing power for anything other than a video game, you were essentially forced to trick the processor.
Check it out.
You had to mathematically frame your scientific problem as if it were a graphics rendering problem. It was incredibly difficult and frustrating.
Well, that sounds awful.
It was, but CUD changed all of that. It was a software layer that allowed developers to program GPUs for general-purpose computing using standard programming languages.
Ooh. Suddenly, you could harness that army of 10,000 middle schoolers for scientific simulations, complex data analytics, and crucially, machine learning.
Exactly. And we really have to emphasize how much of a risk this was for NVIDIA. For years, Wall Street actually punished NVIDIA's stock for the money they were spending developing CUDA.
Because they didn't get it.
Right. Analysts thought they were wasting money on a software platform nobody needed, but NVIDIA was playing a long game. They seeded the market. They made sure their consumer-grade gaming chips, the ones inside everyday laptops, were CUDA compatible.
Oh, that's smart.
It meant a broke computer science grad student in 2012 could start experimenting with parallel processing and AI directly on their dorm room laptop.
Here's where it gets really interesting. By getting to the universities and the researchers early, the resulting network effects were staggering. I mean, universities built their entire computer science curriculums around CUDA.
Yes.
Research labs built their supercomputing clusters around it. Massive tech firms adopted it as the absolute gold standard for machine learning. The CUD is essentially the shared native language of artificial intelligence.
That's exactly what it is.
It's like how English is used as the default language for international business. Like, even if a linguist invents a slightly more efficient, scientifically perfect language tomorrow, no global corporation is going to switch to it.
Because of the switching costs.
Right. Because everyone's entire infrastructure, all their historical contracts, all their employee training is already deeply embedded in English.
That analogy gets right to the heart of platform economics. When we look at NVIDIA's ultimate competitive advantage today, it isn't just they make fast GPUs. Their impregnable moat is their platform ecosystem CUDA.
The software trap?
Exactly. They created barriers to entry that extended far beyond the physical design of the silicon. Let's say a rival semiconductor company miraculously designs a new AI chip that is, say, 20% faster and 20% cheaper than NVIDIA's latest flagship model.
Which would be a huge hardware victory.
In theory, yes. But if that competitor's chip cannot run CUDA software, the enterprise developers simply will not buy it.
They won't touch it.
No, because to use that slightly faster chip, A company would have to spend millions of dollars and years of time completely rewriting their entire stack of complex AI software from scratch. It is simply too expensive and carries far too much operational risk. That is the power of developer lock-in.
It's the ultimate defensive moat. You don't just build a better product, you make the switching costs for the customer so painfully high that they don't even consider looking at your competitors.
Precisely.
Which inevitably brings us back to the incumbent, the giant in the fortress, Intel. Tracking this historical shift forces us to look at the massive existential crisis NVIDIA's ecosystem dominance has created for Intel. And it sets the stage for the future battlefield of computing.
Intel was caught entirely flat-footed by a paradigm shift. For decades, their core strategy of anchoring on CPU performance and their massive manufacturing scale was incredibly successful. They had no reason to doubt it.
Until the ground moved.
Right. The underlying structure of global computing demand quietly shifted underneath them. The rise of cloud computing, large-scale data analytics, and eventually generative AI increasingly demanded parallel processing, not sequential logic.
And we can't ignore that Intel was facing severe internal struggles at the exact same time. It wasn't just that the market wanted GPUs, it was that Intel started stumbling on their own home turf.
The manufacturing delays?
Yes. If we look at their strategic challenges in recent years, they suffered massive, highly publicized delays in their semiconductor manufacturing processes.
This is a crucial point about the difference in their business models. Remember earlier we discussed Intel's integrated model. They design and manufacture.
Right.
That is a massive advantage when things are going perfectly. But when Intel's factories hit physical engineering bottlenecks trying to shrink the transistors down to microscopic levels, their entire pipeline froze. They couldn't just take their chip designs and ask someone else to print them.
Because they're locked into their own factories.
Yes. Conversely, NVIDIA operates on a fabless model. They only design the chips. They rely on external manufacturing giants, primarily TSMC in Taiwan, to actually print them. So while Intel's massive factories were struggling with delays, NVIDIA was able to ride the wave of TSMC's manufacturing excellence.
So Intel's historical technological lead evaporated right as the market decided it wanted a completely different type of processor. And while Intel was trying to fix its factories, these alternative computing architectures, NVIDIA's GPUs, were happily capturing the high-margin workloads in the data centers that had traditionally belonged to Intel's CPUs.
Now, to be fair to Intel, they are not simply resigning themselves to defeat here.
No, they're fighting back.
Strongly. Recognizing the sheer magnitude of these market changes, they have initiated a massive company-wide strategic transformation. They are committing tens of billions of dollars to rebuild their manufacturing leadership, opening new foundries, and fundamentally restructuring how they build chips.
It's a massive bet.
It is. They are also developing and acquiring their own new accelerator technologies, specifically aimed at artificial intelligence, to try and break into that parallel computing market.
They are desperately trying to build a brand new fortress while the old one is sinking into the swamp. And that brings us to the ultimate strategic lesson for you, the listener. Whether you are analyzing the tech sector, automotive, retail, or finance, the rule is the same.
The rule applies everywhere.
Dominant firms can remain highly profitable, they can look absolutely invincible on paper, while the fundamental technological paradigms shift gradually beneath their feet. Inflection points are incredibly hard to see in the moment until the industry dynamics have already flipped.
That's the scariest part for an incumbent.
Definitely. By the time it was painfully obvious to everyone that parallel processing was the future of computing, NVIDIA didn't just have a head start, they already owned the market. So what does this all mean? Looking at the trajectory of this rivalry, the battle for next-generation computing, can Intel's brute force manufacturing investments ever actually break through NVIDIA's entrenched AI software ecosystem?
This raises an important question, and it perfectly frames the core rivalry moving forward. We are no longer just looking at a battle of raw microchip performance. We are watching a collision of two entirely distinct competitive philosophies.
Two totally different approaches.
Exactly. On one side, you have Intel relying on their historical strength, integrated manufacturing scale, and their unparalleled decades-long experience in processor design. They are betting that pure, unadulterated manufacturing muscle and supply chain security can eventually force a wedge into the AI market.
And on the other side?
On the other side, you have NVIDIA. Their primary advantage is no longer just the hardware itself. It is the platform ecosystem. It's the massive developer community irrevocably locked into the CUDA software and their fundamental architectural alignment with the mathematical demands of artificial intelligence.
So if you're sitting in a strategy meeting today, looking at your own competitors, the lesson here isn't to just watch who is building a slightly better version of your product.
Not at all.
It's manufacturing scale versus ecosystem leadership.
Hmm.
It is hardware muscle fighting against software stickiness. The lesson is to watch who is quietly changing the underlying language of your industry.
Precisely. The outcome of this specific rivalry between Intel and NVIDIA represents much more than a competitive struggle between two semiconductor firms. It reflects a deeper transition in the architecture of computing itself.
It really does.
It asks the question, what kind of moat will dominate the next era of digital innovation? The physical, capital-intensive mode of manufacturing, or the intellectual, developer-driven mode of software platforms?
It's a phenomenal question to sit with. And it ties this entire journey together beautifully. Because the primary takeaway from this deep dive is that in the modern tech economy, ecosystems and platforms can become just as powerful, if not significantly more powerful, than the raw technological performance of the hardware itself.
It's about the world you build around the product.
Exactly. NVIDIA didn't just win because they had the right chip at the right time. They won because they actively built an entire world around that chip, a world that AI developers simply cannot afford to leave.
And that's the real victory.
Right. Understanding this dynamic, how invisible architectural choices, sunk costs, and platform lock-in actually dictate market dominance, gives you an incredibly powerful lens for analyzing future business battles, no matter what industry you happen to operate in.
And as we consider those future business battles, there is a lingering thought that constantly emerges from studying this history.
Oh, absolutely.
We've seen how the foundational architecture of the modern artificial intelligence revolution, the exact technology that is currently reshaping global labor, economics, and warfare, was originally built just to make video game graphics look a little bit better on a teenager's monitor.
It's pretty mind-blowing when you think about it.
It forces you to look around today and wonder, what highly specialized, seemingly trivial technology being built right now at this exact moment might accidentally become the indispensable infrastructure of the next century.
That is exactly the kind of question we love to leave you with. Thank you so much for joining us on this deep dive into the Silicon War. Keep looking for those invisible architectures shifting in your own industries, and we'll catch you on the next one.